Hello and welcome to the continuous testing webinar part 2 with special guest and software testing envoy Paul Gerrard. And I'm your host, Simon Knight. Hello, Paul.
Hi. Envoy this week, am I right?
We've had a we've had a few technical issues just kicking off the webinar, so apologies if you've had a little bit of confusion jumping onto the actual webinar itself. Thankfully, we have got it started off now, so everything else should proceed according to plan, we hope. As you'll no doubt be aware from the title, this webinar is the second part of a two-part series. If you missed the first, then you can find the video for the first part of the webinar on our blog or on our YouTube channel. And if you do go to the blog or YouTube, then please hit the subscribe buttons while you're there. In part 2 of this webinar being part 2, of course, Paul's going to talk about the contribution that testers make in a continuous delivery environment. He's going to share a little bit about what continuous delivery actually means, both in theory and in practice. He's going to talk about his new model for testing in a continuous delivery context, and what continuous testing looks like from planning through to testing in a continuous understanding kind of context. Once Paul's done, we should have time to take some questions as well. We've got some housekeeping announcements as usual, so we'll be keeping everybody on the webinar on mute throughout the entire thing. If you've got any questions or comments, please do share them with us in the GoToWebinar chat console. I'll be monitoring those throughout the webinar and picking up any interesting questions to talk about at the end. If we don't get around to answering your question, then we'll try and follow up with it in the blog post or at a later stage. And we are recording the webinar and we'll share it with you in the blog as soon as the video has been processed. So as I mentioned, I'm Simon Knight, I'm your host. I'm also the TestRail product manager. If you've got any product related issues, questions or suggestions about how we can improve your TestRail experience, then please feel free to reach out to me. And also we have Paul Gerrard with more than 30 years of experience in the software development, testing and consulting business, with a proven track record of innovation and leadership in the world of testing, quality assurance and test assurance. He's a regular publisher of articles, an author, renowned conference speaker and winner of multiple testing industry awards. High praise indeed, eh, Paul? Are you blushing?
Yes, seriously. Thanks a lot, Simon. Shall I kick off?
I think you should. Yeah, let's go.
You're gonna hand over control?
Let me hand over the controls. Yeah, it's always awkward this bit. Hold on. Let me look for the thing. Change presenter. Then I have to go find you on the list. Bear with me. Paul Gerrard, organizer. There we go. Over to you, Paul.
Thanks, mate. Right, thanks a lot, Simon, and nice to be back. So this is part 2 of a series. So I'm kind of going to crash in to like where I left off last time, and I hope you're kind of reasonably familiar with this kind of picture which describes the way that most organizations are looking at continuous delivery as like an infinite loop. And although I'm a bit critical of the notion of having this idea of an infinite loop, which looks a little bit like a staged or waterfall process wrapped around and twisted and God knows what, let's live with it all the same. And if you like, what I talked about last week was the left-hand side of the loop, let's call it. And it was really about understanding the definition delivery. So what I was really trying to cover was the notion of how testing will get engaged with the source of knowledge, the people who are creating requirements, defining requirements, challenging them, as well as trying to get to grips with the meaning of these requirements for the purpose of testing, So the way I kind of summarized how testers behave, if you like, in the early stages of a requirement or a story, if you like, it's all about understanding the requirement, and then formulating tests on the back of that knowledge, and then understanding, if you like, the delivery, the actual delivered code, the software that's based on that requirement. So I tried to introduce this idea of understanding both definition and delivery as a way of kind of giving you the helicopter view of what testers' contribution is going to be. It's helping team understanding of the definition and the delivery of software and systems. Now, what I want to talk about today is I want to speak a little bit more about execution. So in that left-hand side, I want to describe a little bit more of the thinking behind what execution is all about. Given that continuous delivery is largely based on automated processes, or at least that's the intention, I want to talk about automation at some length, because this is kind of perhaps the biggest challenge to testers as to how we trust automation to do what people or testers did, let's say, manually in the past. And I think this is not a challenge that's been properly addressed yet. And in some ways, every organization has to tackle it in a different way. But I think the important thing at this moment is to understand what that challenge is, and then to, I hope, give some suggestions of how you take it on as a kind of difficult, almost philosophical problem as to whether we should trust tools as much as we should trust people. The optimization side of it is it's becoming a popular term of the description of how we monitor systems in production in the field, and we're looking to improve or optimize the customer experience. And I'll talk about that towards the end, and just drop some hints as to how I think the world is going in this direction. There's lots of talk about customer experience, but actually a lot of it is very informal and anecdotal as to how we create better user experiences, and kind of that's what it's all about. Now, just to sort of recap a little bit about what I talked about a couple of weeks ago, if you look at the top right, the model, or my model, this idea of the thinking processes that testers go through, I focus very much on the left-hand side of that model, which kind of maps to the left-hand side of the continuous delivery infinite loop, if you like. And so the areas I covered were like the brown shaded areas, top right. And what I was trying to suggest was that rather than think of the status of features in terms of the column on a kind of a Kanban board or a task board, I think a better way of doing it, because of the dynamic nature of continuous delivery, we consider how we're thinking about a feature and use that notion of thinking as to what we regard its status as. So initially, we inquire, we model, we use that model to make predictions about the behavior of software. We can use those predictions to challenge our sources of knowledge, our users, if you like. And then we can use that knowledge to inform the development or the design of tests. Refining is also where we learn more about the system and software to the degree that our model is incomplete or inaccurate, and maybe we have to refine our understanding, our model. So if you like, what the new model idea is all about is defining the thought processes that increase our understanding of the requirement, the definition, if you like, and the delivery, the delivered software, the quality, if you like. So that's kind of where I was last week, where I drifted into the right-hand side, but didn't really get into execution. I want to finish that story off and then move on to automation and talk about optimization too. Now, just to summarize what I mean about this idea of understanding is I could call this talk about continuous testing, but what I want to suggest is actually testing is a means to an end. The goal, the end, is to improve team understanding of the definition and the delivery. And to summarize, in the plan phase of the infinite loop, if you like, the goal is to trust the requirements, to challenge them, to get a common understanding of what the requirement actually means, so developers can code with confidence and testers can create meaningful tests. And tests that will be stable, which is kind of critical, because what we don't want is to be creating code or creating tests that change over time because we don't have a clear understanding. So we're attempting to understand in the best way we can the requirement, the definition as early as possible and as completely as possible. Now, that's an impossible task. You know, imperfection is always out of reach, but that's the goal. Okay, the goal is to trust the requirements to have meaningful tests that are stable. In the code build and test phases of the loop, there's the whole collaborative aspects about building meaningful tests, largely automated, but also we have to fit in exploration of the delivered software to understand how it behaves to the degree that we know how to test it. So this is a very dynamic part of the development process, in that there's code being written, changing daily, hourly even, with testers making their contributions, working very closely with developers, almost on an hour-by-hour basis. So it's very hard to describe it in a way that's other than it's a very dynamic, collaborative, constantly fed back kind of process. And if you like, the team at that moment, at that period in the iteration, they are responding to events every hour, literally every hour. Things come to light which influence perhaps the requirement, perhaps the code, perhaps the testing. So the whole notion of this phase of development is that there's very close interactions and constant feedback between the participants in the team. So this idea of continuous understanding seems to me it's a better way of thinking about what we're trying to achieve in that phase of our continuous delivery iterations. So that's kind of where I'm at. So I want to move over to the right-hand side of the picture in front of you, and I'm going to talk about informing and refining, and then everything to the right, and just work through what I would call the definitions, if you like, but I'm just going to summarize them very briefly to give you a sense of what I'm talking about. So informing, which is kind of middle upstairs, if you like, on the diagram, we're using the knowledge we've gained through inquiry and modeling. We use our model, our understanding, if you like, to inform our test design. So we're in this phase of informing if we're thinking of creating test ideas, cases, data, expected results, you know, the mechanics of creating usable, executable tests. Now, these tests might be scripted, you know, with a tool. They might be scripted, you know, in text. They might be simply written on a few neurons in our heads. I kind of don't care how we capture that information. The important thing is we're using our understanding to derive meaningful tests. That's what informing is about. Now, when we've got our test together, whether it is in our heads or it's on paper or it's captured in the functionality of a test execution tool, applying is the dynamic execution of that test, either by the tester using their fingers and their brains, or using the tool, or by some other piece of magic that hasn't been invented yet. So however we apply those tests, I don't care. That's kind of a case of logistics, which I'm trying to avoid, because as soon as we get into logistics, as I said last time around, you start getting into site-specific behaviors and team-specific behaviors and technology-specific behaviors. I'm trying to stay above that, okay? So applying is the execution of tests. Now that includes the, if you like, comparison of an expectation with the actual behavior. So the match, mismatch, pass fail, if you want to use that terminology, I don't really care whether you do use pass fail as a label for this activity, but that check is done at this moment in the applying phase. And by mentioning checking, again, there's a thinking out there that the mechanical execution of tests is called checking. I'm very happy with that definition. I'm not so happy with the definition of testing as everything other than checking. However, applying equals checking in my kind of view of the world. We're applying if the tests are being run to obtain a match between an expectation and the actual delivery. Now, when we run a test and we get a match or mismatch, usually there's some human intervention to interpret that outcome. So whether we're running one test and saying, yes, there's a failure, but is it a failure in the system under test? Is it a failure in the environment? Is it a failure in the technology that's running that test? Is it a failure in the definition of the test? That's what I mean by interpretation. Partly it's about trust. Do we trust the test to tell us what we need to know? at which point a fail described by a tool is a failure. We trust that. But it could also mean that we're looking at a whole suite of tests where we run 100 and 97 pass and 3 fail, and somebody has to make the call to say, well, what do we do next? So interpreting is about, what I would suggest now is a human judgment that has to be applied to understand what the outcome of a test actually means in the context of our next decision, to ship code, to reject it, to fix a bug, to rethink our design, whatever. So interpreting is where we use our intelligence to decide what to do next. Now, clearly, when we run tests, we need to share that those outcomes and those interpretations, I would suggest, to I would call our testing stakeholders. So the whole purpose of testing is to gather information for typically other people, our stakeholders, to make decisions, to release, to keep going, to fix bugs, to rethink the whole design of the system, whatever those outcomes might be, those decisions might be. So reporting is where we share information with stakeholders derived from our test outcomes and interpretation. Now, logging is the label I would use where we've identified test mismatches and believe that failures have occurred. So logging is what you would map directly to bug reporting or incident tracking in a traditional process. So we are logging, I would suggest, our status is logging if we're communicating failures to stakeholders and developers and other participants in the project. And it might be that we simply give the nod to the developer across the desk from us and say, look, I think I found a problem here. Let's take a look and decide what to do next. But it could be a very formal process where an external supplier logs a bug, and then that's communicated to the customer for prioritization and the technologist for a proposal for a resolution. It could be very formal. It could be a simple informal chat around a desk and just a discussion and debate about what to do next. But logging is where we log mismatches, failures, if you like, and these trigger a process where we have to resolve or accept a compromised system, if you like. Finally, refining is where, when we run tests, we might learn things that we didn't know before. So we might run a whole series of tests and discover that actually our understanding of the system, our understanding of the requirements, the definition of the system is at fault. And actually we need to go back to refine our model to say, well, hold on, did we really understand the requirement? But potentially refining could cause us to go right back to the very beginning and question the requirement itself. We never realized this is what the requirement would imply and cause a behavior that we're uncomfortable with. So it might be there's some kind of conflicting outcomes depending on two tests, or a bit of ambiguity and actually a lack of clarity in what the software should do in an undiscovered kind of scenario or unexplored scenario that the users never thought about. So typically refining triggers some rethinking of the model, or potentially might take you right back to the users and say, we've got a problem because the system seems to do things that don't make sense in the bigger scheme of things, and the requirement may be incomplete, ambiguous, or so on. So those are the 6 kind of thought processes, if you like, which map directly or indirectly to physical activities like creating tests, running tests, interpreting tests, logging bugs, and so on. So every organization will have a slightly different perspective and approach to addressing the issues raised by these thought processes. But I'm trying to stay above that, as I said earlier. I'm trying to stay above that so that we can think about what we think about and then make choices in the logistics and the mechanics and the actuality of how we implement these processes. We can separate the two things, okay? So if a consultant ever says, as a little sidebar, if a consultant ever says, you should log bugs in this way, that way, and the other way, I think they're giving you a solution that might be appropriate for some contexts, but not all, and probably not yours. And that's kind of why I'm not dipping into that level of detail. So the new model, makes no assumptions of context. It's kind of context neutral or context blind. I don't care what technology we use in this conversation I'm having with you now. I want to suggest also on the left-hand side and probably beyond, the thought processes for developers are the same as those for testers. And by this, I mean, a developer will inquire, ask questions about a requirement. A developer will build mental models to construct the design of code in their heads, perhaps, or to jot it down as some kind of flowchart or flow graph or some state model or whatever. The developers have to create tests. They have to use their model, their understanding, their mental model, in order to create meaningful tests if they're doing test-driven development or if they're testing code that they've just written in a traditional way. I think all I'm trying to say with this is the new model for testing is actually, I think, universal for the participants in the project, except the goal of testers is to do testing, the goal of developers is to write code, but actually to test that code. So I think ultimately the thought process of developers are very closely aligned to testers. Now, don't get me wrong, I'm not saying they have the same thoughts. What I'm trying to say is the modes of thinking that developers go through and testers go through are almost the same. I think their thoughts are different. Testers and developers might well build different mental models for the same functionality. Now, one other thing to pay attention to is I want to suggest that we may be using tools to apply tests or humans to apply tests, but the interpretation and the other decision making that's happening in the new model idea is done by humans. Maybe in the medium term, tools, AI, machine learning, artificial intelligence, whatever, may take control of some of these things if we can trust them to think the same way as humans, to analyze the outcomes of tests in a similar way to come up with meaningful decisions. Right now, I think we're in the very, very early stages of that. And to be honest, I don't think we'll make progress with AI until we get our thinking straight as a traditional human tester. And if you like, that's my goal, my priority in trying to deconstruct testing into these thought processes. If we don't think straight, we'll never get testing that we need to apply and never get requirements that are tested by critical thinking, critical people to get better requirements. So I'm very much focusing on the thought processes in order to get our thinking straight to make better decisions about whether we use AI, machine learning, artificial intelligence to support some of the decision making. So I want to look now at the whole idea of using automation, and I think trusting automation is probably the way I would summarize what I want to talk about. I'm going to talk about automation and just look at some of the pitfalls, but also I think where the new model perhaps can help you understand where we go wrong. Before I do that, it's been quite a debate for some years now where is there such a thing as test automation? When we talk about test automation, are we talking about the analysis of requirements, the creation of test cases, the generation of test data and execution and interpretation? No, of course not. And yet some people, let's say non-technical managers running development teams might believe that testing can be automated soup to nuts, but no tester believes that's the case. And the whole idea of the new model, and one of the reasons for having this concept of a series of thought processes is, if you like, the one area where tools, if you like, take complete control is in this idea of applying. Now, some people would say, no, applying, that's checking. I don't care. I think applying and checking are virtually the same. I think that the difference is, I'm not clear about what they are, other than they're very subtle. But let's, for the sake of argument, assume they are the same. Applying is where you adopt a mechanical process to execute a test. I think tools do that, clearly. I think humans can do that too, but that's not a good use of human, if you like, processing power or thinking or just effort and time. So I want to talk a little bit more about this idea of left and right, and just want to, if you like, do the helicopter view of automation and testing in general, because I think automation and where it fits, if you believe it fits in this applying phase or state, I think the discussion is almost the same. because people can make a hash of executing tests in just the same way as tools can be misapplied and misused and misinterpret the outcome of test automation as well. So I want to suggest this, that the thinking on the left contributes to the definition of features, the whole notion of testers challenging requirements to the degree that they are trustworthy requirements. They provide a clear definition of behavior. The opportunity, if testers are involved in the debate, discussion, collection of requirements, it's the tester's opportunity to challenge them, because the tester kind of is best placed to come up with scenarios, tests if you like, of those requirements to demonstrate whether a requirement is meaningful, sensible, or inappropriate, ambiguous, incomplete, in conflict, whatever. Testers have a fantastic opportunity to get stuck in and improve the quality of requirements through doing what comes naturally, to challenge other people's thinking. Now, the models on the left, or the understanding which we achieve through modeling, are blueprints for both the tests and the code. The developer uses the same definition as the tester, clearly. Now, we may not be writing down requirements in mountains of text, reams of narrative prose, but what developers need, and testers need too, is a clear definition of need, of behavior, if you like. The developer writes code and writes tests to validate, verify that code. The tester independently, perhaps from a different perspective, certainly with a different model, maybe a usage model as opposed to a technical code coverage model, they will use a different model to come up with tests that validate requirements in a systematic way, a meaningful way. So the models on the left are the blueprints for the tests and the code on the right, and the automation naturally. So if you don't have this clear understanding of the definition of the software, you can't write code, and you can't write code that tests that code. You have to have clarity and understanding of the definition before you can create meaningful test automation. It's not just a case that you can take some delivered software that executes a transaction, captures some user data, executes a transaction, that all you need to do is to simply fill in the boxes, press the button, and hope that a message comes up that looks reasonably meaningful. There's a lot more besides in terms of the test design, because the test design is derived from the definition of the functionality, in the same way that the code that's written is derived from the definition of that functionality. So, to summarize this, if you are applying automation to muddled, loose, incomplete, flaky features, we're just writing some test automation after the code is written without any real deep understanding of the requirement, that's doomed to fail. Okay, there's no debate about that. I mean, we've all done it. We've all had that experience. If you as a tester and are responsible for testing and maybe test automation, you aren't involved on the left, you don't have an input to the definition of the requirements, to challenge those requirements, I'd say you aren't in a good position to test at all, whether you're using test automation or you're doing it manually. If you don't understand the requirement, you cannot come up with meaningful tests. And certainly tests that people will pay attention to if you discover what you believe are anomalies. So I just want to sort of set a little task for you almost. It's to challenge the thinking that people have about what automation actually does for us. Okay, so a lot of people think that tools are just drones. We script a test to run a test that generates an outcome that we trust, and we use and reuse that script to re-execute the test to generate an outcome that we hope is consistent with previous runs. We're just looking for a tripwire to tell us that we've changed something that should not have changed. Now, regression testing has value, but regression bugs, there's no real fixed data on what proportion of bugs regression bugs represent. but it's something like 10 or 15%. It's the minority. Regression bugs can be very painful, but they are in a minority. But also, what we really, really want to do is to use automation to find bugs in new, untested software. So what I want to suggest is that the way we should think about test automation is not as a drone that simply does what we codify it to do. I want you to think of test automation as an extension of your mind. So in the same way that your hands and eyes and ears support test execution when you think of a test, I think we need to move much more closely to regarding tools as natural extensions of our thinking. If we can think in terms of models and we capture that model in some format, tools can read models, can generate test conditions from models, can generate test combinations from models. Maybe the automation really does contribute to test design, test selection, as well as test execution. I'm certain that we need to think much more carefully about how tools use models to drive test execution rather than we just write code based on some model that is never captured. And there are now tools, I think, coming on the market that are paying attention to this. And I think you'll see more and more in the next few years that tools become, by default, model-based test execution engines. They won't be code-based so much as model-based. I think that trend has already started with 2 or 3 products on the market. I don't think I need to comment on that. I've said it. So why are we using tools? What are we trying to do with automation? Essentially, we might run a test to demonstrate a feature passes meets some requirement in some way at some time. But ultimately, we're trying to demonstrate, we're trying to detect unwanted side effects of changes beyond the new code that's arrived in a system. I want to suggest that we have to collaborate with developers, users, business analysts who are defining, articulating requirements. We have to collaborate early to have a shared definition for this to work well. And I want to suggest that the goal is not to find bugs with automation. The goal is to demonstrate what I would call functional equivalence. This new version of the software behaves in the places I'm testing in exactly the same way as it did yesterday or the day before or the hour before, whenever it was unchanged. The image I have in my head nowadays is like a cast and the mold that created it. So if you like, if I'm casting something in clay, the mold and the cast fit perfectly, but when I change something, there's a discrepancy and the two don't fit together anymore. That's how I think of these things. It's a much more visual way of thinking about this mismatching idea. And I think we have to start using models to describe and articulate how we identify areas where mismatches are most likely, regressions are most likely, but also how we identify those regressions by having meaningful tests that highlight that kind of problem. Now, one of the things that I will also have to say is the tools we use are sensitive instruments. So I've got a surveyor there who's using maybe a laser theodolite to look at the change in height between 2 corners of a building or 2 areas of land where you're trying to build a road or a bridge or another building. And the precision of these instruments is extremely high. But where we use test automation, it's a bit like we're using highly accurate sensitive equipment to detect movements of feet and meters. So if we're using very sensitive tools and our software, our system under test, our bridge is unstable, tools don't help. They almost get in the way. We can see with our bare naked eye, there's something going terribly wrong in this picture of the Tacoma Narrows Bridge you might be familiar with. So tools get in the way if our software is unstable. So one of our goals one of our challenges rather with test automation is this notion of instability within the system under test. So in a continuous delivery regime or environment, there is constant changes to the software. If we don't talk to developers constantly, we're going to miss these changes and miss the background to why these changes occur. and therefore just have tests which are out of step very quickly. And if our tests are out of step by like 1%, we can kind of recover very quickly. But if we turn our backs on the development team for, say, a week, we discover actually 20% of the code has changed, and suddenly all our tests are all at sea. They don't work at all. They don't map, they don't synchronize, they don't reflect the new version of the software. So it's got to be the case that we have to work closely and work early with the developers and the people who are defining the requirement itself, the definition side of things. And I've made some suggestions on the slide, which I won't dwell on too long, but the whole notion of test automation is it needs to be very closely aligned with the coding process itself. The code, changes in the code must be reflected in the test code as well. Now, it's not necessarily the case that we'd be reflecting minor code changes which have no impact to the user interface or the external behavior. It might be a performance change or whatever. But the whole notion of stability means that we have to be in the same place as developers. We have to use the same mental models, or at very least, we have to use the same understanding of the requirement to understand what's driving changes to the functionality, so our changes to test automation can happen in parallel. Of course, for this to happen, we need extremely flexible and available environments, test data, and the whole mechanics of creating an ecosystem where we can run tests and trust the outcomes. The whole notion of this, though, is that test automation and the management of test automation, whether it's by an individual or by across a whole team of people working in different if you like, work units or delivery teams, test automation is critical to the delivery pipeline. We can't separate it. You can't just treat it like testing has traditionally been treated. We'll do it at the end. It just doesn't work. So one of the things that is the basis of continuous delivery in the first place is this kind of mantra that if you have a partially automated process, the parts that hurt the most are the parts that you should work at and focus on most closely, because they might be slow, time-consuming, unreliable. And if they hurt, we need to understand why the hurt occurs, but also if we do them more often, we tend to learn how to do them better. If we can do them better, more efficiently, we have a kind of a process to follow, perhaps the opportunity is there to automate it. So there's this kind of mantra of if it hurts, do it more often, automate it. That's how it works. It's the same with test automation, in that if it hurts to do test automation, we're kind of doing it wrong, but we need to persist to understand why it hurts and how, from that understanding, from that knowledge, we can do it better. So part of the game I've been probably preaching for the past 20 minutes or so is to bring the thinking of testers to the left, to the requirements phase. I've said this again and again. So shift left as an approach to improving testing, to improving quality, to improving the possibility of delivering more rapidly, is that we have to shift the test thinking left to eliminate mistakes in the code and testing and test automation. I would argue that it's not a technology problem. Tools fail not because the tools are poor implementations of poor technical implementations. Tools fail because we don't have the same mental model, the same definition as our developers, because we're not staying close to them. We're not sat in the navigator seat right next to the pilot. So I want to move on to talk about trust for a moment. I mean, this is the question. This is the big, maybe philosophical question for testers who don't use automation, is can we trust automation to do all our testing? Well, if you define testing as the 10 thought processes, certainly not. We're really only talking about the applying activity, the test execution activity. Now, normally, in most environments, our developers will automate all their tests, all their meaningful tests will be either test-driven, test-first kind of approach, or they exist as tests after the event. But developers usually automate their tests and upload them into a continuous integration environment. Test of APIs, maybe at a higher level, because we're testing bigger pieces of functionality. But the same thing applies because there's no user interface to an API. It's a programmer's interface, not a user interface. Again, these tests are usually automated. In fact, they're always automated to some degree, but they're usually integrated into a CI system in the same way. There may be tests of functionality across perhaps different configurations, whether it's operating systems or mobile devices or versions or browsers or whatever. This is kind of such a painful thing to do manually that we usually try and automate this as a matter of course, or we hire some external agency to do it for us. And then what's left are tests that can only be performed by a human. The tests that we believe are kind of intuitive, based on detective work, exploration, study, thinking, and so on and so forth. But I want to argue this, that the thought process to come up with a test that you automate is exactly the same process as a test that you run by hand, if you like. So I want to suggest that if we treat tools as an extension of our thinking, all tests become possible. So all tests that we want to apply, if we use that definition to apply, all tests that we want to apply in principle could be automated. Now, what we lose when we run a test is we lose this idea of the observer. So a tool will look for specific behaviors and compare behaviors with expectations, perhaps. What a human does is they look around, they see a bigger picture, they notice things that the tool may be perhaps not looking for. That's what we lose. But that looking around idea is simply another model. And if we can encapsulate that model in some form that a tool can understand, I don't see any reason why we cannot automate tests that a tester would think of, would dream of, if you like. So if we are to trust automation to the degree that we are fully automated in the pipeline from commit from the developers through to delivery into a production environment, if we're going to trust automation to make those transitions in an automated way or an autonomous way, let's say, we have to get our head around the problem of modeling the problem so that a tool can execute tests in that way. So we have to consider exploratory testing as a mechanism for creating automated tests. We should stop sort of not committing. We should commit to saying all the tests I can think of, at some point, I want a tool to be able to run them. We're not there yet, but I don't see why we can't get there in time. So just to step back again on this whole shift left idea, and I've said, well, shifting left is a strategy, moving testers from a team at the end of the process to embedding them with developers to take full part in the collaboration activity. What the things we can do is, yes, we're going to do storyboarding and challenging and so on and so forth. We're going to push more responsibility to developers where we can, and we're going to give more support to developers to run tests in an automated way. Now, that will get us part of the way, but we've got to reduce our dependence on automated end-to-end and user UI tests, GUI tests, if you like. And this is absolutely consistent with the testing pyramid, which I'm sure many of you are familiar with. Shift left helps us to push the emphasis down to developers, to technologists, to write tests using technology to implement them. We've got to start thinking of where a tester thinks of tests, the technology will take it over, potentially the developer will implement that change. So how will shifting left reduce doubt? There are some kind of behavior changes, I think, that are required for us to do this. Testers, we're not the gatekeepers of quality. We're not the conscience of the project. We're not the last defense. We're not the only person who cares about quality or bugs. We have to move away from that and be much more or much less judgmental, and much more kind of, if you like, independent minded and dispassionate, you might say, like a journalist. We are there to investigate and communicate. We're not there to judge, okay, either the people or the delivered software. So testers have to become kind of pathfinders. We have to be risk managers at a high level and make sure those risks are being addressed by somebody somewhere. we have to ensure that the tests that are significant and meaningful are included in the automation, perhaps. So we have to think and act like a visionary. We have to sort of take a very high level view, but be prepared to drop down and interfere, if you like, to get down and dirty with developers, to talk to managers who are making decisions based on incomplete information all the time. We're also a coach, mentor, maybe to developers, to users, to whoever is testing in our team. And yes, of course, we do some testing too, but it's a much more broad activity than just creating tests, running tests, logging bugs, doing retests, doing regression tests. There's much more to it, I think, and our contribution can be much greater than that. So I want to sort of close this talk with a little oversight, or maybe an overview, I should say, of what's being increasingly called customer experience optimization. So the customer experience you will understand already, I'm sure, but this idea of optimization, I want to just say a few words on this. I'll refer to a friend of mine, Anthony Edwards of Eggplant, the CTO, who put a slide out with these statistics derived from people like Gartner, Forrester, World Quality Report, and so on and so forth, and Eggplant's own survey. And I want to highlight this statistic, or these two statistics here. It's like that 72% of teams say they lack visibility of their quality status. So 3/4 of teams saying people do not know the status of the software. They don't know where they are. They don't, they're on a journey, but they don't know where they're at on that journey. This is kind of criminal, in some ways. How can testers call themselves professionals if they cannot tell people where the project is at, if the project does not understand where it is at with a feature? Now, the second one is really stark, and it's kind of universal. And you know what? We all know this, and we've always known this all the time. 98% of teams lack confidence in their ability to predict the impact of changes. What's that saying? It means when we formulate a requirement to do X, and this requirement X is going to increase the registration rate or sales or conversion rate or whatever it is, some business outcome, 98% of people have no confidence that it's actually going to work. We are creating requirements for functionality where we are almost completely in the dark about whether it will work, even if we delivered it in a perfect way. Now, that is a real damning indictment of software in general. Now, you could say, well, 98%, I mean, that's probably, the question probably wasn't formulated well, but I think it reflects a lack of confidence in our processes, in our people, in our tools, in our technology, in the whole show, in how we deliver software to meet good, better, positive business outcomes. So customer experience optimization is about driving towards positive business outcomes, these PBOs, whatever they are, inquiry rates, registrations, conversion, sales, whatever they are. So when we monitor in production the behavior of our software, our business systems collect data on performance, business performance, of course, but we're also monitoring all manner of behaviors in our users through what's it called? Gosh, my word's gone. Through the monitoring of button clicks and where mouse movements and sequences of activities within our applications. Instrumentation was the word I was looking for. The challenge is to create models that can be used to predict positive business outcomes. What we really need to be able to do is to say this feature or performance change or usability change will lead to improved customer enquiries, sales, or registrations. So we need to know whether the change we're making today will have a positive business impact. Now, potentially, we can't do this because we rely on guesswork, on completely unproven, assumed models. But what's coming more and more, and the organizations like Amazon and eBay and Google have been doing this for many years, what we're now beginning to be able to do is to monitor business outcomes and get data on improved performance or a performance that fails. What we can now do, though, is with AI and machine learning and stuff, this is beginning to emerge. we can map those positive business outcomes, these good things, if you like, we can map them to metrics captured earlier in our project process. So it could be we achieve a positive business outcome through better test coverage. I don't know, maybe that's true, maybe not. But we've got the data that potentially we could infer that to be the case, or vice versa, that poor coverage is leading to poorer business outcomes. It might be the defect density in selected components. Some components are constantly being changed, and when we change it, we have a negative impact on the business outcome. The length of test scenarios. So it could be the length of the user journey to achieve a desired goal could be getting longer and longer. And by making it longer, by making our tests longer journeys, we recognize actually this leads to worse outcomes because users get bored and they pull out, they bail out before the end, and so on. So all the metrics we can capture can now be compared and married to business outcomes, and machine learning will look for patterns, for models, if you like. And where we can derive these models, we can then use those as an input to the test activities, to the definition of requirements as well. So look forward in the next few years to much more clarity on how we take the models, that the machine learning models that are coming out of the data we're capturing and monitoring in production. Look forward to more inputs coming into the requirements process, which will influence the requirements for sure, but also how we test, because ultimately testers are aiming at improved business outcomes. So to close, so I want to suggest in the last two sessions, I've tried to suggest that continuous testing requires testers to change their behavior, their thinking in particular. And I've tried to use the model to describe how our thinking works and how it could be transferred from waterfall to agile to continuous delivery, or any process that comes our way in the future. Testers have to move away from passive, staged end of project, end of cycle activities to proactive, active collaboration, to challenge and refine requirements, to collaborate with developers to understand what they're doing and to influence them in the right direction. We need to understand the whole notion of customer experience and this idea of optimization with predictive models coming along. This will come sooner or later. We're going to see these making an impact in what testers do. We have to act a little bit more like a pathfinder or a navigator in projects. We're not a passenger on the plane. We are actively helping the team to take the right direction. So we're much more proactive than reactive. You have to also, I have to say, be prepared to operate at both the business level with users and managers, but also down and dirty with the developers in the technology stakes as well. We're getting drawn into conversations which span the whole technology stack, as well as the whole business process end to end. This is a very demanding thing, and not everyone will be able to do it. But I think this is the way that the best testers around will have to get their heads around. So let me finish with this, that I think overall what will help us think more clearly about continuous delivery is that this idea of the goal of testing is to increase the understanding of the definition and the understanding of the delivered software. Almost, I would want to replace the word testing with understanding now, and just move towards this, if you like, higher level, this higher frame of reference to better understand what we need to do as testers in projects. And with that, I wish you luck, and I'll thank you, Simon, for taking back control.
Thank you, Paul.
I think I overran there.
It was a bit longer than the last one, certainly. I'm just trying to figure out how to take back control now. There we go. All right. Yeah, it's certainly longer than the last one. Lots of great content in there, though. Certainly worth a rewatch to dig into some of the finer points of what you were saying, I think, Paul.
Thank you.
So let me take a look at the questions. So I've got one just to kick off, because I think for some reason people tend to leave sending over all their questions till right to the end. So while I'm taking a look at those and collating a few more, you talked a lot about models throughout the webinar, and I mean, it seems to me, right, that I mean, based on one of the slides quite early on in the webinar where you talked about how developers and testers, they're basically thinking in along the same lines on the left side of your new model, right?
Yep.
In the sense that they're modeling the system or the software or whatever that's going to be developed.
Yep.
And you talked a little bit about how model-based test execution tooling is going to become more prevalent over the next few years.
Yeah, I think so.
So I guess, yeah, I mean, I guess so I mean, what occurs to me is that, you know, bugs, issues with the thing that we're trying to accomplish arise because although we're thinking along the same lines, the different roles, the different people involved in a project are all using slightly different models to think about the system, right? So you've got product owners, business analysts, those guys, they're thinking about the system in terms of requirements models. Developers are thinking about it in terms of, you know, some kind of code model, you know, patterns for actually developing the system. Testers are thinking about maybe in terms of end-to-end scenarios, all of that kind of stuff. And we're all using different models. So with that being the case, if we move to model-based test execution tooling, is that kind of a panacea, a silver bullet? If we're using the same tool to model the system as we are to sort of execute our tests against the system, is that going to solve a lot of those kind of issues, do you think? And just by the way, when you answer this, you might want to expand a little bit on what we actually mean by models in the first place, because that's something that somebody was asking in the forum as well. It's like, what even is a model?
Okay, good. I'll start there then. That's a good place to start. I mean, the thing about if you imagine the challenge we have with software, but let me suggest that the challenge we have with life in general is our world is so complex in every respect that our brains somehow have to come to terms with this complexity and allow our physical body, let's focus on something relatively simple, though it's still complicated. We need to take a few steps from A to B. In order to do that, the processing power required to balance a human being, the tensions in all the major muscles, the angles and configuration of all the major bones in our body, to take a single step requires computers that are way beyond the sort of thing you have in your phone or desktop. You know, you've almost certainly seen movies of these robotic dogs which can do remarkable things, but they have fantastically sophisticated computers running a mathematical model in order to make progress. What humans do is we don't have computers anywhere near as good as that, as fast as that. So what we do is we build incredibly sophisticated mental models to simplify the problem to the degree we can manage that complexity. So just to take a few steps, humans can do this without much failure. We are fallible, but we make adjustments all the time. It's almost like an organic process. But we simplify the world through modeling. And I would substitute the word understanding for modeling or models throughout my talks, because what we're talking about is we model in order to understand. Now, when a developer looks at a requirement, they will come up with some mental model which says, okay, I need to put some components together. I've got some fields, got some data, got a database, I've got some validation rules, and they will pull together all these kind of you know, sometimes very complicated requirements to achieve all these things at the same time, and write code and build screens and build interfaces and so on and so forth. Now, that model that they have in their head is geared towards the construction of code. Now, when a user comes along and uses it, they don't see those requirements in the same way. They just want to implement the behaviors that are described by those requirements. So their mental model of the complex system is probably in terms of a business process with a customer at the end of the phone, with some money exchanging hands, nothing to do with software. So users actually use systems using mental models which are very different from the models that developers use to construct that software. Now, a tester is kind of caught in the middle. They want to, they have a role of trying to verify the software and the V&V kind of idea. They would like to verify that software has been built correctly according to the way the developer thinks. But they also have a role to say, look, can we validate this software to the degree that a user can make use of it to achieve positive business outcomes and so on. So the models that testers use, whether they are working side by side with developers, or they're working side by side with users, or they're a system tester or a large scale integration test, whatever, they use different models depending on, if you like, the risks they're trying to look at in terms of the usage patterns they're trying to simulate and so on. Now, so that's that. So that's the way the world is now. Now, we don't always write these models down. A lot of things are guessed and a lot of things are put together in people's heads in testing, and that's fine. That's just the way it is. But we are modeling, endlessly modeling. What I'm trying to do is bring that modeling to the fore and recognize that's a really critical skill. But also, if we can articulate models to the degree that they are reliable, meaningful, and so on, they simplify and they do what we want, we could use a tool to take that same model to generate tests, to execute tests, to calculate coverage, measurement, and so on and so forth. So what tools are beginning to emerge to do are things like scanning a web page to identify all the fields, to take the informal exploration of testers to build paths between those elements on screens and the button clicks and so on. And then once that model is there, we could then enhance that model by editing the model within a tool, and then use the tool to generate permutations, combinations, calculate measures of coverage, as well as to run those tests directly. And I think that's where we're seeing model-based testing kind of advancing most quickly, I think. And there's about 3, 4, 5 tools. There's 2 or 3 I know of, certainly, that are working this way. And I think you'll see more in the next few years, because it's what we all want to do is eliminate code from test automation. You know, why are we writing code to do what humans do naturally? We should be understanding the model that a human is using and using that to drive the process through a system under test. So that's where I'm coming from. Modeling is model-based test execution is the way to go. I stand by that.
Okay, so I mean, there's several comments in the questions that I'm getting over from Jim Hayes, and so just to mention Jim, Paul will see these questions. I'll send them over to him and your comments and such. There's a question here from Charles Chandler. What's the difference between tools that read test models and data-driven test automation? And I'd argue that there's no difference. Data is just a different model of the system, right? But then if you follow that line of thinking, that would probably make all test tools model-based testing tools, wouldn't it?
I think there's 2 things going on. One is the flow of control within let's say you're looking at a web page. One is the flow of control between elements and across elements in a web page. And you can build a picture, a model of the interactions that a human has with those fields. Now that is not the same. So, you know, so moving between fields, putting data in, seeing error messages, all that kind of stuff, great stuff. That's one model. Another model would be, I know what data is to be captured. I know what rules of validation rules are to be implemented, and I know what calculations could be done. So I could build a spreadsheet to define a set of test cases which exercise boundaries and so on and so forth. Now that model is of no use without the model of the interaction between the user and the system itself. So we can have a model of a data model, if you like. Let's look at it that way, and we can have a physical model of the application as well. You need both. Now, at the moment, people are writing code to do the physical model. There is no physical model. We just write code. It's hard coded. It's the worst programming practice there is, to hard code things that change. Some tools are now moving towards identifying elements on screen automatically, and then using that to build a model and to use that to look at paths through the screens. But there's no knowledge of data in what the tool does through the user interface. that requires insights from the people who define the business rules and the validation rules and the calculation algorithms, all that kind of stuff. And that's a separate model. So we have, I don't know if we're ever going to get towards a single tool that will do both, but there might be two integrated tools that do test data management, test data generation, combinations, permutations, but that's a separate model from the model of the execution model between the tool and the user interface. At the moment, I don't see anything. There are tools that integrate and will combine to do that, but there's no single tool, I think, that will do that, both things yet.
Okay. All right. Moving away from the model-based testing tools, I'm going to finish off with this question, I think, and this, I guess, applies to both part 2 and part 1 of the webinar, so kind of the whole thing. That this change of thought, so continuous testing, can be a challenge for testers to assimilate. Any suggestions on how to boil it down for management who doesn't necessarily understand the testing process well to begin with?
Okay, I would say the role of the test, if a manager says, right, we're going to get rid of our external independent test team and embed our testers with developers, I think you lose one thing, which is a focus of attention at the end. But the goal is to bring the thinking of testing to the left. Okay, so that's the first thing. Bring the thinking, not necessarily the bodies of the thinking of the testers, to the left. And the next thing is the testers should be allowed to ask any question they like of requirements, of implementation, of code, of users, of anything, and to contribute. Their contribution is to expose those answers and to expose schisms, discrepancies, ambiguities, and so on in the thinking across the team. Because I think teams fail because everyone thinks they understand what they're trying to achieve, but actually they've all got a slightly different vision of the end product. So the role of testers is to ask possibly awkward questions and to expose mismatches of thinking, lack of understanding, misunderstandings, conflicting understandings, all that stuff. That's the role of testers, to increase team understanding of the definition, the requirements, and the deliverable, the system itself, the system of the test. So I'd say there's three things: move left, ask questions, ask any questions to expose lack of understanding in definition or requirements, definition or delivery. Sounds like three bullet points to me on a slide. So there you go.
Great answer, Paul. Thank you. Okay, ladies and gentlemen, that was Paul Gerrard. Paul, thank you very much for doing that for us. Paul's working on an ebook, I think, covering off the two webinars in ebook form, I guess. So hopefully we'll have that published fairly soon, along with a bunch of other of Paul's material that he's done for us as well. So watch out for that. So I guess it just remains for me to say thank you everybody for attending the webinar. There's no poll at the end of the webinar today, but our customer survey is going out next week. So please watch out for that if you are a TestRail customer. If you're not, please do feel free to go to our website and take out a free trial. One of the things I noticed while you were talking, Paul, you talked about the eggplant report saying 72% of teams lack visibility and confidence. Well, all I would say to that is clearly they're not using TestRail, right? Because if they were, they would have complete visibility and confidence in their ability to release a product, quality product. So yeah, definitely. Definitely go and give TestRail a trial if you have not already done so. And the other thing I was going to mention is we don't have a webinar in December, but Ranorex, our sister company, is doing a TestRail integration webinar on the 17th of December. So I'd encourage you all to sign up for that via the link on this page. Paul, thank you once again, and thank you to all of our attendees for joining. See you in the new year.